Dear all, welcome to the lecture series of Basic Electrical Engineering. In this video I will be discussing analysis of AC circuit with a pure capacitor. Before explaining, you need to know what is a capacitor. You know, a capacitor is an electrical component used to store energy from the electric field. That is actually the capacitor. Okay, it's a passive device. It has two electrical conductors separated by a dielectric material that both accumulate charges when connected to the power source. So it will be like this. So as you can able to observe, there are two parallel plates separated by a dielectric medium. This is actually the dielectric medium. We can call it D. D stands for dielectric medium. This is plate number 1 and this will be plate number 2. So one plate will be having positive charges like this. Other charges will be having negative charges. Okay. So you have to remember in this fashion. One plate gets negative charge and the other gets positive charge. That's the speciality of capacitor. A capacitor does not dissipate energy unlike resistor. In case of resistor, it dissipates energy, but capacitor, it does not dissipate energy. You know that capacitor block DC, okay, and it pass AC. The reason I will tell you afterwards. So these are the basic information about capacitor. There are different type of capacitor, and you must have observed this is actually called a ceramic capacitor. Okay, here polarity doesn't matter. No need to consider the polarity. The capacitor which will be having higher value, okay, it uses the ceramic for the dielectric material. What type of dielectric material is used here? Ceramic is a dielectric material which is employed between two plates. Ceramic disc capacitor does not have a polarity. You can connect any point, not a problem. While connecting in PCB or anywhere, you can connect your own manner, no problem. In ceramic capacitors, the physical size, there is a small physical size. Okay, high capacitance with small physical size. That is the advantages of this kind of ceramic material. And it is having high dielectric constant. Its value ranges from picofarad to 1 or 2 microfarads. And if I talk about the voltage rating of ceramic capacitor, voltage rating is very less. Next, you must have seen this kind of capacitor that is called electrolytic capacitor. If you want to connect electrolytic capacitor, you have to see the polarity. And when you need the high voltage rating, if you want to go for higher voltage rating, you can select the electrolytic capacitor. And also it is mainly used for filter design to reduce the ripple voltage. These are the purpose. And also coupling capacitor, it can be used as coupling of two stages of circuits. You can able to use coupling capacitor. And there are two thin films, it is made up of with aluminum foil, okay, and there will be an oxide layer of insulator. This is basically a polarized based capacitor. Then there are many more varieties such as silver mica capacitor, film capacitor, then trimming capacitor, etc. Paper capacitor, many are available. So I have given a brief information about capacitor. It is used for storing the charges. Okay, it stores charges from the electric field, and it does not dissipate energy. Okay, it's a passive device as well. Let us see what about the behavior of capacitor when it is connected to AC supply. Consider a circuit, a capacitor, a supply is provided, V is equal to Vm sin omega t. Now what is the speciality? Here voltage is lagging behind the current at an angle of 90 degree. That is the speciality. Why it is happening? Or else you can say that current is leading the voltage at an angle of 90 degree. Both the manner you can able to state how it is happening. I will be explaining that. First of all, we need to consider V is the potential difference at any instant. Let Q is the charge on the plate at any instant. You know that charge is equal to charge Q is given by capacitance into voltage, one of the popular equation. This equation you have to remember. Please call it as equation number 1. And you know that the V will be varying sinusoidally, like V is equal to Vm sin omega t. Now do one thing. The current, the equation for current, I is equal to dq by dt. This you must have studied at the first module, dq by dt, rate of change of charge. Okay, charge flow with respect to the movement of charge with respect to time, that is called a current. So I is equal to dq by dt. Now do one thing, instead of q, you need to write cv. So it becomes like this, d by dt of cv, d by dt of cv. So C can be kept as it is. Instead of V, you have to put Vm sin omega t in this fashion. Then what you can do is, you have to do the differentiation. I, you can have omega C, that will be constant, and Vm will be taken outside, and cos omega t. D by dt of cos sin omega t means cos omega t. Not only that, multiplied with omega as a chain rule. Now what you can do is, current. From this you can able to write I is equal to Vm divided by 1 by omega c. I will be writing, for my convenience I am going to write 1 by omega c. So Vm by 1 by omega c into cos omega t can be written as in terms of sin omega t. That means sin omega t plus 90 degree or pi by 2. Or else we can able to write Im is equal to Vm divided by 1 by omega c, where Im is the peak value, right? This is your Im. Hope you are understanding. This is your Im, peak value, Im. So therefore we can write I is equal to, instead of Vm by 1 by omega c, I am going to replace with the Im. I is equal to Im sin omega t plus pi by 2. Okay. Now please recall the equation. I is equal to Im sin omega t plus pi by 2, where V is equal to Vm sin omega t. V is equal to Vm sin omega t. What are the differences you can able to observe? See, compared to current, voltage is lagging. Voltage is lagging behind the current at an angle of 90 degree. Since it is an ideal case, we can talk about 90 degree. But if it is non-ideal cases, it may not be 90 degree, less than 90 degree. However, we can say that voltage is lagging behind the current. It is very clear. Here the 1 by omega c, we have written as 1 by omega c. What is 1 by omega c? 1 by omega c is known as capacitive reactance. It is denoted by the letter Xc, capacitive reactance. X is equal to 1 by c omega. 1 by c omega. Else we can write 1 by c into 2 pi f. 1 by c into 2 pi f. Okay, this is the equation for capacitive reactance. The capacitor offer a resistance in a particular AC circuit that prevents or that opposes the movement of current due to presence of capacitance. It's the reactance which is offered by the capacitor is called capacitive reactance. Of course, it blocks DC. Why? Because you can put for DC frequency will be 0. So 1 by C into 2 pi into 0 means 0. 1 by 0. So definitely we can able to say that it may not flow DC. It blocks DC. So we can't get the particular value. It's not determined 1 by 0. True. So we can say that a DC block capacitance. The graph shows that relation between voltage and current. Look at this. Voltage is written as a reference. Voltage is drawn as a reference value. The like V is equal to Vm sin omega t. It is going to start from 0. What about the current? Current is leading by the voltage at an angle of phi. So we will be writing like I is equal to Im sin omega t plus phi. Therefore, current should be starting above that particular voltage. So there is a leading. Current is leading by the voltage at an angle of phi. Here phi can be written as pi by 2 for ideal case. That is true. Now let us understand instantaneous power. P is equal to Vi. So Vm sin omega t into Im sin omega t plus 90. Now what you can do is sin omega t plus 90 will be cos omega t. So sin 2 omega t. Sin 2 omega t means 2 sin a cos a. Same formula you have to elaborate. Vm Im into sin omega t into cos omega t can be written as half Vm Im to sin 2 omega t. Then if you want to compute the total power consumed in a circuit, you have to do the integration like Vm Im into 0 to 2 pi sin 2 omega t. If I do the integration, it will be 0 only. So we can able to say that in a power consumed, in a average power consumed in a capacitive circuit will be 0 only. And also the frequency, it will be doubled. Power wave in psi wave frequency double that of the voltage and current wave. So maximum power value of instantaneous power is equal to Vm Im